Hello everyone. In today's session, let us discuss one more topic from AI, which is alpha beta pruning, which comes under game theory. So before getting into the example, first let us know what is meant by alpha, what is beta, and what is pruning. Okay. So this alpha beta pruning is similar to the minimax algorithm, which if you have not watched that particular session, please go back and watch that and then continue with this. It will be easy for you to follow. So here alpha and beta are same as the minimax. Always the max will update the alpha value, which is the highest value among the alternatives. The beta will update, min will always update the beta value, which is the lowest value. And pruning is, we will try to eliminate some large parts of the tree. Okay, here also this follows DFS only. So at most, at any cost, we will be seeing only the nodes along a single path in the tree only. So you need not worry about the other path. And in the alpha beta pruning, when we apply this to a minimax tree, it returns the same move as minimax would. But what it will do is, it will prune away the branches that cannot possibly influence the final decision. I'll show you how we will prune. Okay, so the result of this pruning is, in the best case, the time complexity will reduce almost by half. So here you can see the complexity is big O of m by 2. So half of the branches you can eliminate. Otherwise, at least only 3/4 of the tree only you will try to explore, not the entire one. So the complexity will reduce to big O of b to the power of 3m by 4. So the same example that we have used for minimax only, I'm considering again, so that it will be easy for you to follow. And we will try to apply this on one fresh example as well. So here is the algorithm. So here you can see that initially alpha beta value. So similar to minimax, we are starting with minus infinity and plus infinity. And finally, final value of this V has to be returned. So now, if you see this max value, I'll just show you the termination condition. So when the branch has to be pruned is, whenever the value that you are computing, if it is greater than beta. So what is the value that we will update at the max player? It is the value of alpha, right? So whenever alpha value is greater than or equals to beta, you will prune the next branches. Okay. So similarly, coming to the min player, we try to update the value of beta, right? So whenever this beta value is less than or equals to the alpha value, you have to prune. Otherwise, you can update the value of alpha by taking maximum of alpha comma v, and you can update the value of beta by taking minimum of beta comma the fresh value of v that you are computing. The other details are similar to the minimax algorithm. Let's try with this tree. Okay, so first we will be starting with the root node. Okay, so at the root, the initial values are minus infinity and plus infinity alpha beta values. Okay, so the same values will be propagated here. So for time being, you just ignore this value. Minus infinity and plus infinity will be propagated here. Next, coming to the next one. So here, this is a terminal node. So it will return the utility value. So the value that is returned is 3. And this is the min player. Okay, so in the min player, what we will try to do, always we try to update the beta value. So the initial beta value is infinity. So that will be updated with this 3. Okay, so here, this is the updation, minimum of beta comma v. So minimum of infinity comma 3, minimum is 3. So it will be updated with this particular value. Next, the next value that we have is 12. Okay, so this 12 is compared with 3. 3 only is less. So the value of beta is not updated. Next, we will compare with 8. Okay, so 8 is less when compared to 3. So the value of beta is not updated. It is the same thing here. Here you can see the value of beta remains the same thing, which is 3. Okay, so this is a min player. The value of alpha will not be updated here. Okay, so if you want, even you can keep this value to minus infinity only. But one step if we go ahead. Okay, so here we will be updating the value of max by taking the value at this particular node. What is the value at this particular node? Okay, so this is a minimizing node. So the value that is returned here is the value of V. So that is 3. Okay, so the value at this particular node is 3. So the minimum among 3, 12 and 8, which is 3. So that is the value of this particular node. Okay, so now the same values will be propagated back to the root node. Okay, so at the root node, so this is the maximizing node, right? Okay, so which is maximum among minus infinity and 3? 3 is maximum. So the value of alpha got updated with 3 and the value of beta remains the same. We are not touching here. So only I told you here to keep minus infinity comma 3 to avoid the confusion. Otherwise, you can also update this infinity with the value of the node, which is 3. So that is what given here in the textbook. Okay. So now we are exploring the next node. So when you are exploring the next node, okay, so the values that you will be observing is the values that you have at the previous one. So what are the values that we have? So it is minus infinity, okay. So in BFS, the values at the root node will be propagated here. So the value that we will be taking at this particular node is 3 comma plus infinity. Okay. So now here the value of 2, this is a minimizing one. So the value of beta has to be updated. So value is 2 here. So here the value of beta is infinity. Okay. So 2 is less. So we will update this value with 2. Okay. But now before update, one more condition that you have to check is whether the value of beta is less than or equals to alpha. Yes, here 2 is less than or equals to 3. So we will not explore the next nodes. We will be pruning them. So these two alternatives we will not even explore. Okay, so simply we will be pruning these two. And we will take 2 as the value at this particular node. Okay. So taking 2 as the value at this particular node, we will go back. Okay. So actually in the textbook, he has given this minus infinity, but actually the value here has to be 3 and plus infinity. The same value will be propagated here. So and after updation, this will be updated to 3 comma 2. So take the value 3 comma 2 instead of taking minus infinity comma 2. Okay, let's explore the next alternative. So okay, so far what is the value that is taken here? So we are exploring the next alternative to see whether we have any other value which is less than 2. Okay, so we will take these two values 3 comma 2 and we will try to propagate this to the next one. Okay, so here the value at this particular one is 14 and this is a minimizing one. So we will not update the value of 2 with 14. We try the next alternative. Again, 5 is not less than 2. So we will not update. And coming to the last, 2 is equals to 2. Okay. So the value of beta remains the same here also. So here the value at this particular node will be taken as 3. Okay. So now to compute the value at this particular node. Okay. So here the value that we have obtained is 3. So here the value at C is 2. And here the value at D is 2. So out of these three, whichever is maximum, that will be taken as the value here, which is 3. Okay. So this is the final V value that is returned. So at this node, we have a value 3. And if you see the computation here, so the final value of alpha is also been updated here. So from here. Sorry, I'm checking for my cursor. Okay. So here in this tree, if you see here at this level, we have a value 3 for beta, right? So that value finally at the final stage we are updating. So which is 3 comma 3. Final value of beta, which is maximum 3, 2, 2. Among these three, the final value which is greater is 3. So this will be taken as the value of beta. So now let's try the same thing with one more example. And if you see one simplifying task, I'll show you here. So if we are applying the alpha beta pruning on the minimax tree, right? So what it will do, first what we are doing is we are trying to take the minimum of 3, 12 and 8. Okay, so minimum of this is 3. Next, we are trying to take the minimum of 2, 4, 6. Okay, 4 is pruned, 6 is pruned. So we are marking them as x comma y. Okay, since it is a minimizing node, anyhow the value of these three should be less than or equals to 2. Already we have a greater value which is 3. So you need not explore the other two. That is the intention. And if you are applying on the next sub branch. So among 14, 5 and 2, minimum value is 2. So now the maximum among these three is 3. So if you are following the minimax algorithm also, you are getting the same value 3 at the root. But the only thing is in the alpha beta pruning, we are pruning parts of the tree so that you need not explore the other parts. So now let's try with one more example. And before going to that, so here what we have seen, whenever a player has a best alternative M, okay, and he has one more alternative also N somewhere in some other path, okay, but the best is M. So when it is decided that M is better, we need not even explore the other path. So simply this will be pruned off. So now let's try with this particular example. So this is a maximizing node. Okay, so the initial values will be minus infinity, plus infinity. Here, minus infinity. Same, it will be carried here in the initial stage. Okay, so now this value has to be updated. So this is a maximizing player. So initially 2 is compared with minus infinity. Alpha value has to be updated, right? So this minus 2 is updated with 2. And with these values, we move on to the next alternative. So here the value we have is 3. So 3 is greater than 2. So this value will be updated to 3. So the value at this particular node we will have is 3. Next. So the same values will be propagated here. So we have a value of 3 and infinity. So the same value will be forwarded here. Now, so if you compare, here the value that we have is 5. So this is a maximizing player. Okay. So we have to update the value of alpha. So we will be updating that with a value of 5. 1 second. So here actually this is a minimizing player. So the value of beta has to be updated. Okay. The value of beta has to be updated with the minimum among 3 and infinity. The minimum value is 3. So this will be updated with 3. And let's not touch this part. We will keep the value as it is, minus infinity. Okay. So the value that is propagated here initially is minus infinity comma 3. So now we are taking the value of alpha. Okay, so which is this utility value 5. 5 is greater than minus infinity. So it will be updated here. But here it is a maximizing player. Okay. Whenever your alpha value is greater than or equals to beta, we have to prune the next sub branches. So here value of alpha is 5, beta value is 3. So you need not explore this. We will be simply pruning this particular path. And we will not even update the value. So we will keep it the same. So what is the value that we have? Okay, so this is a maximizing player. So this value we are not going to update. So this we will not even consider. Okay, so the value that we have at the max player is 3 infinity. So that we will be updating here. Okay. And now we are trying to check, do we have any other value which is maximum than this? Okay. So let us forward this value here. Okay. So 3 infinity. Okay. So now among 0 and 3, 3 is maximum. Fine. So among so this is a maximizing player. So the value at this particular node is 1. Okay. So this 1 is compared with the minimizing player will always tries to take the minimum value. Okay. So compared to infinity, 1 is minimum. So here the value will be updated to 1. So the same thing will be propagated to the max player here. And here we will see that whenever at the min player, whenever you have beta value which is less than or equals to alpha, the other part we will be pruning. So I will not even explore this particular part. Okay. So it will be pruned off. So now from here, the value at this particular node that we have obtained is, at this particular node, the value that we have is 1. Anyhow, this is a max player. So out of 3 and 1, the maximum value that we will be getting is 3. So which will be considered as the value here. And from here, so the value of alpha also will try to update. Finally, this will become 3, 3 and the value at the root node again is 3. So hope you followed. If you have any queries, please let me know in the comment section and try to solve this example with the help of the algorithm and by considering the previous example. If you like the content, please do like, share and subscribe. If you want any other topics, please let me know in the comment section. Thank you.